Hey guys, today I wanted to set up a Postgres server on my Kubernetes cluster. I do want to run you guys through essentially how we're going to structure this and why we're going to structure it this way versus other ways. With this, you can see I kind of have some stuff laid out, but I want to walk through exactly what's going to happen. With Postgres, you can just install it using Helm. Helm is a very powerful tool. Comes with Kubernetes. It kind of like lays on top of it. You should learn it if you haven't. If you're in the Kubernetes world, it just allows you to set up Kubernetes in a much more organized manner. And when we use a Helm install of Postgres, what we end up getting is a stateful set of essentially 3 nodes. So, well, 3 nodes, 3 pods. The first pod is a master pod, and then the second and third pods are what are called slave pods. Essentially, the master pod, anytime there's data being written, it's written to the master. You can also read from it. You can also read from these other 2 pods as well. So with this is kind of how Helm install of Postgres is set up. It's more of a simple type of pod orchestration. Thing to keep in mind is that this is a stateful set, which essentially tags each of these pods in a specific way. So this is pod 0, pod 1, pod 2. And essentially, anytime this were to go down, like let's say the master pod were to go offline, this slave pod would then be promoted to the new master pod. And anytime data is written to the master, it is copied subsequently to the slave 1 and then slave 2. What this allows you to do is you have high availability, because if the master were to go down, we would have automatic promotion from one of the slaves in the system, and then same for slave 2. This would be promoted to slave 1. So this is all built into the Helm orchestration of this Postgres install. And something I want to also go over is how we're going to actually set this up. So the next thing I want to look at is like us having some app namespace, right? We have an app, let's say it's a web app, let's say it is, some website that we're wanting to deploy that has some data being kept in it. And in that data, I want to keep it in Postgres. Now, one thing I could do, and I've done this before, and I realized why you shouldn't do it, but one thing we could do is we could set up a Postgres instance inside of this single namespace, right? So in here, I have my 2 pods of the same app, and each of these are conferring with our stateful set, right? That makes this namespace have 5 total pods. So that's something to keep in mind, right? Each of these has to have resources allocated. Each of these has to be tracked and managed, and it's quite a lot. So I kind of wrote out essentially what the problems are here, right? It's resource intensive, resource wasteful. There's an increase in complexity, right? Because now I'm managing 5 separate 5 separate pods, technically 2 different types of applications, my web app and my Postgres, and then it's just more to manage. And then you have duplicated functionality, and that's what I really wanted to get into. When you're running a Postgres server, it comes baked in with the ability of having separate databases with separate users and a whole OAuth flow for those users. And our web apps are essentially just users to Postgres. So there's not much benefit to setting up a Postgres instance in a specific namespace unless you really need it separate from any other app namespace. So a better alternative to this is to do something like this, where we have a Postgres namespace and then our app namespace, right? And this Postgres namespace essentially just handles the stateful set. This guy will be how we install our Helm for Postgres. We will install him to ensure that he's running in his own namespace, isolated from everything else. And then when I run my application, right, this guy needs to communicate with Postgres. This can be done through internal service calls through Kubernetes. Kubernetes handles a lot of the networking for you, and you can just do, and like for the internal networking, you can kind of see, I wrote it out here. You have the service name, namespace, SVC, cluster, and local. And what this kind of turns into is Postgres 1, which is we're going to have a service based on Helm, comes with the Helm, and then PostgresQL, which is our namespace, right? And then this is how this app will actually connect to him. And one other step that you need to do if you're going to take this approach is we're going to have a job for our application, right? And this job will create the database, create the user, and then add the user to the database, right? This will run one time, and the only thing he requires is the Postgres database password, the admin password. So we can use a Helm install for our application. When it's installing our application, the first time it can create a job that then creates the database in our Postgres server, creates the user and adds the user to the database. And then subsequently, the apps can use this user and the password that it provided to connect to our database. And then he is essentially isolated from any other application that might be hosting a database, right? This is very powerful because it allows us to simplify complexity, right? Because we don't have to manage multiple Postgreses in each different app namespace. We have it all in one system. And then if we want to do backups too, it's also easier because I can just take backups of the whole Postgres server with all of the different databases in it. And since I'm able to create the databases within this server, I take those snapshots daily. I don't have to do anything super special. I don't have to set it up multiple times per app. I only have to do it once for my entire cluster, and I'm good. So that's the idea here, and that's what I'm going to get into as we continue. So continuing on, I wanted to go ahead and jump into getting PostgreSQL onto your cluster. So here, I have my cluster dashboard open. From here, we're going to go to our apps, and on apps, we're going to hit repositories because PostgreSQL actually isn't along with the default applications. So to be able to do this, what we're going to need to do is add it to our rancher. To do that, you can go through the UI. I think it's the easier way to do it. I'm going to name this PostgreSQL. I can call it repository, and then I'm going to leave this in the description below. The thing that this is an OCI repository. You just need to paste the link into here. From here, you should be able to then just hit the create button. You should be able to hit the create button. Make sure you have a name that's actually valid. So you can see here PostgreSQL repository. And then if I go to in charts, I can go here, type in PostgreSQL. I now have the option to actually install it. Very simple. From here, we're going to go ahead and install this into a custom namespace, just as the diagram had showed. To be able to get this custom namespace, you just need to go into this guy right here, the kubectl shell, and then you're going to do some really simple commands. Create kubectl, create namespace, PostgreSQL, right? So that way we have our PostgreSQL in its own namespace. And then I'm going to name this Helm chart. You have to give it a name. I'm just going to name it PostgreSQL. Keep it simple. So in the values YAML, we're going to want to change a few different things. One being this architecture. We're going to want to change it from standalone to replication. Replication gives you the stateful set and what I'm actually looking for, where you have the high availability. If you leave it on standalone, it will only set up a single instance of the Postgres server, which again isn't high availability. And then along with this, we have Postgres password. This guy is the admin Postgres. That's his password. So you're gonna do something unique here. Replication password, again, something unique. And then the password, this is for the password for a user, right? So if you change the username and password, it will create an additional user that's just like a custom user for yourself. You don't have to do that since you have the Postgres user. Replication password is important. Replication password key. This is just like the keys for these guys right here. You don't have to specify these. Use password files. I think that's okay. And then database. If you want to set up a default database, you can here. We're not going to do that either. And the only other thing we're going to actually want to update is going to be the amount of space that we're allocating to Postgres. There should be in here, looking at it right here. So I don't want to do 8 gigs. I want to do 20, probably 24, so 3x the default. I believe there's multiple spots we actually have to update this, so you're going to want to actually go through and make sure you update them where they need to be. And with changing those two, I believe that it is okay. Mine's still detecting a few others, but I can't find them, so I'm assuming maybe the finder here is just a little bugged out. Yeah, see, there's nothing else. And with that, I believe that's enough. There is some things to note. There's this password update job. So this guy here, what he does is he will update the passwords on a subsequent update to the Helm chart. So if you update the Helm chart and you run this, you can also change the passwords using this. You don't have to run it the first time. You might want to run it in the future or have it set on a cron job to generate new passwords and refresh everything, however you want to do it. It does require previous passwords, so good luck figuring out exactly how you're going to want to do that. So with this though, I believe that's enough, and we can just go from here. So we're going to hit next, and then we can just hit install. And with that, it should be installed. It's not too much, and you can see here how we're going to actually want to connect to it. So there's a read and write connection on PostgreSQL primary, PostgreSQL service cluster local, and then we can also get the Postgres password using the command to actually decode the secret. And of course, we can always open a Postgres client to actually connect to the database if we so deem need to. So this is pretty much everything that we need to do to actually get it running within our cluster. And you can see here in our cluster, we now have an installed app for Helm, and it says right here, it's deployed. So if I go back to my home cluster, my home page, you can see some events for actually our primary PostgreSQL container. And yeah, and you can see the volumes are properly mounted. With this, I believe we are good to go. The next thing I want to show you guys is how we set up the Helm chart for the application when it's creating the job that's going to run to create that portion of the database right when you're installing the app for the first time. So let's go ahead and jump over to that. Hopefully you guys have a pretty good understanding on Helm. I'm going to walk through this. I don't think there's anything too crazy here or super special. You can see here, I have an if statement to say, hey, if this job is enabled, then we're going to run it, right? So just see if PostgreSQL is enabled. If it is, then it's going to run on the pre-install. So this is going to run before any of the Helm is actually going to be installed. And then in here, we can see that, I just get the app name, just call it database creator. And then the namespace is going to be in the Postgres namespace. And you can see here, I denoted that this is important, that this job runs in the same namespace as the PostgreSQL namespace, PostgreSQL database, because he is the one that's actually interacting with Postgres. If we scroll down, we can see here's our containers, the image is Postgres, the database is this guy right here, DB creator. And then we have the command down here. This command is running just a simple echo, and then on an until that is checking if Postgres is running. This guy is doing this by running this host command that's essentially just continuing over and over until it actually works. Then this actually creates the user and the database. So here, this is first supplying the Postgres password, which comes from down here in the environment. This is pulling from the secret key reference. This Postgres password is the same Postgres password that is supplied by the Helm chart of PostgreSQL. So that's why this is named Postgres password. It's using the one that is already there. So it's nothing too special. You can see here also that is important is the host. It's going through and actually creating that Kubernetes URL so we can actually connect to the pod that we want, which is our primary pod. And after doing this, you can see here, that's what this guy checks. Here, we're going to be connecting to him using this host. We say the user, which is Postgres. We pull his password, supply it. Database is also Postgres. And then the port, if it's special, if it's different, mine's not any different. It's 5437, I believe is what the default is. And then, of course, you're going to do these two commands. Create user, Postgres user. Postgres user is one that I am supplying for the application, and then the password is another one that I am supplying for the application. This is different than the password that is assigned to Postgres. That's important because you don't want a user to have the same password as the admin, right? This is a specific user for our application. He needs to be a unique password with him. And then our database, we create that second because we can immediately say, hey, the owner of this database will be this user. That way he gets all of the permissions as if he were to have admin access to that database, but he doesn't have admin access to all of Postgres, right? So that this allows you to have create that database. I made it really simple. I used the same app name as the application itself, and then the owner doesn't have anything too special, right? It's just supplying that same Postgres user. With this is how I'm setting up the job. This only, again, runs on the pre-install. It won't run if I update my application or anything else. It will only run that one instance and never again. And the only other thing to note is this Postgres secret, which is going to be in the namespace of the application, not the Postgres, right? Even though this is the same name, it's kind of misleading. Oh, it's not actually. I thought it was. No, this is for the application. This is just supplying the Postgres password, the same password that I'm supplying to the user. That way that connection is set up properly. And yeah, this job isn't anything too crazy. I'm gonna make sure I leave it in the description below. And yeah, there's not really anything else to show. Once the app actually runs, or once you actually install it with Helm, then this will run and it will all be set up. I'm not going to do that in this video. I'm going to do it in a future video where I'm actually showing how to install your own application as a Helm chart. But if you would like to see when that video comes out, please consider subscribing below. Leave a like if you like the video, and obviously leave any comments down below on what you think I could have done better, or any trouble or any issues that you're having that I might be able to give you some guidance for actually doing. Thanks for watching, and see you next time.